Hi, and welcome to another mathematical studies video. Now, we talked when we talked about correlation, we said that correlation does not imply causation. Now, the important thing to realize is that when we were talking about correlation, we had two variables at all times. We're correlating perhaps height with points per game scored, etc. Now, we've been so far only dealing with the chi-squared in one variable data. I had a dice, I would roll it and count the frequencies of how many 1s, 2s, 3s, 4s, 5s, and 6s would appear. How do we use the chi-squared in data that has two variables in bivariate data? Now, this is how it works. Now, we will need two variable data like in correlation. Here's an example. Somebody measures the grades of the final grades in math studies of students who hired a private tutor and students who didn't. So here could be the results. Here's a 1, 2, 3s, 4, 5, 6, 7s, and the students, how many students would get what, right? So you have 5 students who got a tutor, got a 2. 12 students who got a tutor, got a 4, etc. Now, here it's interesting. Now I might want to say, well, what would be the expected frequencies out of the total, and is there a big difference for those who got a tutor and those who didn't? Now, I can calculate this using the chi-squared again. And what I'm actually going to be trying to determine is whether the people getting a grade is dependent on whether they have a tutor or not. Now, the important thing about the chi-squared with bivariate data is that it's always done with the calculator. We never do anything without the calculator here, without a graphic display calculator. So very much like in correlation. Let's see a look at how it actually works. First of all, let's talk about degrees of freedom in bivariate data. Now let's look at my table again. Realize that I have all the totals here and all the totals here, right? So the moment that I put this value here, this one is automatically determined because I have a 2 here, so this one is going to be a 1. The moment that I put this 5 here, this one's automatically going to be determined to be a 4. And here, of course, something similar happens. The moment I put this value, this value, this value, this value, and this value, the moment I put this one too, this one is automatically determined out of the total. So all of these values are automatically determined because of the totals. Hence, the degrees of freedom are going to be 1, 2, 3, 4, 5, and 6. So they're going to have 6 degrees of freedom here. Now, again, this can also be done with the calculator, but it is important to give it to you just in case. So how do I get the chi-squared with the graphic display calculator? Let's go step by step through it. It's a bit of a long process. So remember, if I have one variable data, I calculate it using the formula. This method is not going to work with the graphic display calculator if you have one variable data. If I have two variable data, I must calculate it with 2i84. I'm not going to have another method available. So this is how you do it. This is my table. So first thing I do is I press second and the x to the power minus 1, and I'm going to access the matrix menu. Now don't get scared, we're not going to be dealing with matrices. It's just a matrix at the end of the day is just a list of numbers. So I'm just going to put these numbers inside a matrix. Now, this is what opens up. I go, normally it's in names, I have to go right to go to edit, and I choose A, and I'm going to put these values in A. Now, automatically we'll first have to say, well, I want to have 2 rows, first goes the rows, and 7 columns. And I'm just going to copy this table, but only these data. I don't have to put the totals in. I insist, I don't have to put the totals in. And once I put the data in here, in the matrix, I will press that, go to tests, and if I scroll all the way down, I find the chi-squared test. So remember, go to the matrix, choose matrix A, 2 times 7, depends. It's going to depend on what data you have. Here's 1, 2 times 1, 2, 3, 4, 5, 6, 7. Put the data in carefully, make sure you don't make any mistakes. Go to stat, to test, and go to the chi-squared test. Now, once you press that, this is what's going to happen. You're going to have the following menu. It's going to have for the observed and the expected. Now, you might wonder, well, I didn't put anything for the expected in B. Oh dear. No, don't worry. The graphic display calculator is going to do it for you. It's just asking you, where do you want me to put the expected? I will calculate them for you. Where do you want me to put them? And you're going to say, well, put them in B. and that's fine. Now you have two options here. You can click calculate or you can click draw. Now, if I choose calculate, which is what we mostly will choose, this is what's going to appear. You're going to have the chi-squared statistic here. In this case, it's 1.82, 1.83, sorry, it's three significant figures. A p, which we will talk about later on, 0.93, and the f, which is actually the degrees of freedom. The chi-squared statistic, the p-value, and the degrees of freedom. So again, I didn't need to calculate the degrees of freedom in a different way, but it's a good thing to know. If I press draw, this is what's going to appear. Now, this is a distribution curve, like the ones we've seen in a normal distribution. Now, it's not really in the syllabus, but it's not a bad thing to look at it carefully. Now, here's an important thing. It also gives me the chi-squared, and it gives me the p-value. And we get also the probability distribution curve. It's interesting to compare this with the normal distribution. If you want, we can talk about it in class. So, important to realize here is that if I go back and to my matrix menu, I can edit a matrix B and I will be able to see the expected frequencies. Now that might be something they ask for, so it's a good thing to know. So let's talk about this p-value thing. So if they don't give you the critical value, but you're given the level of significance, then I can actually decide whether the data is biased or dependent or independent by looking at the p-value. So I just compare the p-value with the level of significance. So when I calculate in the chi-squared, I get the p-value here. Here I had it 0.9348, and I compare it to the level of significance I have. So if it's smaller, it means that the result is significant and there is a bias, there is dependence. If it's bigger, it's not significant and there's no bias, or there is independence. It kind of works the other way around. It might be a little bit counterintuitive. But just remember, like normally when you get a small chi-squared, you'll get a big p. It's a number from 0 to 1, and it's just a probability. The probability that you have that kind of distribution. So that's all you need to know for now. We will look at more specific and more longer examples of this in the next presentation. Thank you very much for watching. Goodbye.